It's 9 o'clock, so we'll start this webinar now. Of course, if you drop in late, that's fine too, because all of this will be on YouTube for you to look at later. Before I start, there's a few things I wanted to let you know. So you've probably already seen this page, which is the ISOP study group working page, basically. And this is this is good to read, maybe, because this has a lot of information about what we do and the aims of the study group. And here's also the page where you can look at which events are coming, which webinars, and also to request new events. Let's say you want to learn about a topic, you can suggest an event and suggest a speaker for that and a date. Of course, you can also suggest a topic of your own. If you know a lot about a specific topic and you want to share that with the study group, you can create a new issue here. And if you fill this in, for example, dose finding, then you can request to present on that specific topic. So just go to this page, if you have questions about the study group in general, or specific things here, you can open a GitHub issue on the GitHub page. Let me see how to go there. Well, I don't see the link at this moment, but there's a link to get help on this page. Just open an issue on. I actually see it. I have it open here. You can open an issue here, and then your question will be answered. So that's just briefly about the study group. So now we go into the webinar about PKPDsim. I first want to just show a few high-level slides on that. What I promised to go into some example code very quickly. So very high level. What is PKPDsim? It's an R package which you can use to simulate out ODE systems, and it's very specifically tailored to PKPD models, because you can easily implement regimens. It's easy to implement the models that we commonly use within pharmacometrics. It's fast. It's a lot faster than what you probably used before. If you were doing ODE systems in R, you might have used DESolve before. It's very easy to implement random effects and covariates, which I will show in the webinar. What can you use it for? Just a few examples here. You can use it to evaluate regimens, dose levels in maybe in an industry setting or in a clinical setting. You can use it for simulation-based diagnostics like the VPC or the MPDEs. For teaching or model communication, because you can also easily wrap it into Shiny. You can use it for map Bayesian estimation. That's also how I use it on a day-to-day basis. Optimal design. It's fairly easy to wrap it into either PFIM or Puppet, and you could even use it for population level estimation, but I haven't worked with that at this point. So about the package, it's not on CRAN yet, so you can't use install packages yet, but I'll promise to release it soon there. For now, you need to install it with the DevTools package, which is a very useful package to have anyhow. If you don't have that installed yet, you should install it like I shown here. After you install that package, you can just run library devtools and then using the command install from GitHub, and then my repository here, and that will install the package in the normal way. And after that, you can just call the library using this line. So this webinar, I'll just present one or two basic PK models, nothing really fancy. I'll show you how to use the model library and the custom code. Of course, the latter is probably a bit more interesting, so I'll spend a bit more time on that. I'll show you how to implement drug regimens and between subject variability and covariance. If you have any questions during the webinar, you can put them on Twitter. I'll have a look at them at the end of the webinar. Otherwise, if you have questions afterwards, just put a question on GitHub. Probably, if the question is related to this webinar, it's best to put it on the ISOP page. Otherwise, put it in the PKPDsim page on GitHub. You can also email me, of course. So there is a page for documentation, but that's still in development. I'm working on this. So it's probably better if you have a look at that somewhere next week. But there is already some information here if you wanna have a look. So that's PKPDsim docs.com. So let's now go into the webinar, the actual code. So this is, I'm working in our studio, which probably most of you also work in. So let's get started. We load the PKPDsim library. We'll start using a simple model from the library. And we do that by using the command new ODE model. So we have to give it a name, the model, so mod1. And if I just want to use a model from the library, I can actually show you. If you just run this command, you will get a list of the models that are available at the moment. So this is not a long list. I plan to add a few more models here at least, but for now it's just a few very basic ones. But let's choose the oral model. And you will see that the command will take a few seconds to execute. So what happens in the background is that it will translate some of the code into C code and then compile that into a binary. And that just takes a few seconds. But after you compile it once, of course, everything is very fast and you don't have to wait anymore. The next thing is that you need to make a regimen. And we do that using the new regimen command. And we'll just create a simple regimen of 100 milligrams for 6 days and an interval of 24 hours. Okay, so now we have a model and a regimen. There's only one thing missing, and that's the parameters. And that's just described as a list. So now for this model, I might not know what parameters I actually need to use. So to find that out, it's very easy to just type the model, the name of the model, and then you'll see a list of, well, you see also how the model is defined, and you see a list of the required parameters. So now I just need to make a list of a clearance, a volume, and a Ka. And then we have everything to start the simulation. So we do that by saying sim ODE, which is the main command in this package, and then we just need to combine all the information that we created before. So it will ask for an ODE, that's our mod1. It will ask for a regimen, that's our reg1, and it will ask for parameters, and that's our var1. So if you do this and run this, you will create a data set. And if you have a look at that data set, it looks like this. So and I can show you the tail. And you'll see that it will simulate out all the compartments, of course. But most often we are only interested in the observation compartment. So let's do that for now. So just the observations, and now I will only have the observations. And so this data is already in the right format for a ggplot. So from here it's very easy to make a plot from this. You just need to say x equals t and y equals y, and make it a line plot. Oh, I did not load the library. But here we have our data in a plot. So that was very easy. Now to make it a bit more interesting, what we can do is, because this is just one patient, what we can do now is include between subject variability. So if I do this, instead of creating data for just one person, I can create it for 50 persons. But of course, if I just do this, it won't really help, because it will always be the same individual with the population parameters. What I need to do is specify an omega matrix, and that's the same as in non-mem. So the way it works in PKPDsim is that you specify the lower triangle of the omega matrix as a vector. So, for example, you could do it like this. I'm gonna increase the font size a little bit. So here I'm creating the lower triangle of a omega matrix, and one thing to note is that the order of the matrix basically is defined by the order in which you specify these parameters. So this one refers to clearance, this one refers to volume, and so let's leave out any between subject variability on Ka for now, and let's just simulate this. Oh wait, I need to specify by ID, I guess. Wait. These are the plots for the individuals with between subject variability. So one thing here is that like I said, I'm putting all this data into ggplot. What I've made a bit more recently is a library to make that even easier. So the library is called PKPDplot, and you can also install that from my GitHub account. Once you do that, plotting becomes much easier, and will actually have all the defaults automatically. So now we just need to say, after we load this library, PKPDplot, we can just say plot, and it will make the plot a bit nicer and a bit easier. So this is basically the way how to implement between subject variability. Now let's now make a model ourselves without the library. So again, we will start with creating a model, new ODE model. But now we don't say, we don't take it from the library. We say code equals. Then we can define our own. So now we need to specify the compartments, the derivatives, and we do that by specifying it like this. So let's do a simple one compartment IV model, which looks like this, without any covariates or without anything for the moment. Yeah, this should be fine. And again, let's define a regimen. Let's now specify it in another way, actually, because before I used the end command, I can also specify the exact time point. So I can also say times equals 0, 24, 48, 72 for 4 doses, and I can leave this as a single value, or I can also specify a factor here if it's actually changing over time. So let's do it like this. And let's specify it as an infusion now, because before it was just an oral dose, which is basically a bolus into the absorption compartment. I can now make this an infusion, and with an infusion time of 2 hours. So you see that it's very easy to specify. I need to specify new parameters, and that's just a list. And I define my model myself here, so it's just clearance and volume. Now we can do a new simulation. Let's make a plot of this immediately. So here's our new simulation, and to show you that the infusion works, I can increase the infusion time to, for example, 6 hours. So that works nicely. You see I can specify the dose, etc. So that was very easy to basically write our own models. Of course, this was a very simple example, but it's very easy to extend this a bit. And let's, for example, let me show you just one thing that you need to know. For example, which you can also write this model as this, and then say this. If you do this, which is fine, you do need to declare that variable that you're using now, the k elimination. You need to state that you're using that. But otherwise, this should work fine. Again, we get the same plot. So let's just make the doses the same. Okay. So that works fine. To make it a bit more interesting now, we're going to add a covariate. For example, let's first start with adding weight. For example, we will add weight on clearance. So we're going to make a new variable for that. We don't have to, but just to make it clear, we make it a bit clearer. We're just going to multiply clearance with weight over 70. Yeah, let's just do it like this for now. Actually, let's make it allometric immediately. So what you would write in R is you would write it like this to scale it to the power of 3/4. But you need to keep in mind that what you write here is sort of a pseudo C code, and in C you can't use this way of describing a power function. What you write in C is pow, and then as a function basically. So that's the only caveat that you need to be aware of. But otherwise, this will run fine. Except that now, since this won't work actually, because I have declared a new variable, clearance individual. And I'm now also using a covariate, and that's I'm going to make a covariate. To do that, let's call it cov1, and that's actually going to be a list of covariates, because I might add more covariates later on. So we're going to define weight as a new covariate with a value of 70. Let's make it 80. So now I need to define this here, cov1. That seemed to work fine. Now also in my SimODE function, when I call that, I need to define covariates, and that just works like this. So this, I mean, it's a bit hard to see if this actually worked, but you have to trust me on that. One last thing I want to show regarding covariates is how to do a covariate that's changing over time, because weight probably won't change much, but let's throw in creatinine clearance, for example. Let's define creatinine as a covariate. I'm just going to implement a very simple model here. So we have covariate values here for creatinine, for example, 0.51, 1.52. But now we also have to define the times, basically. So let's define the times equals so these are the times at which these are measured, basically. Let's make it a bit more extreme to show the effect better. Now I need to recompile the model because I've added a time varying covariate. Something went wrong here. Oh, I didn't define this correctly. So, and another bracket. Okay. Now we need to recompile the model, and I run the simulation again. So let's see what happens here. Not sure why it's not doing. Let me just bring this up. It's hard to see if it's changing over time. I'm not sure, actually. Oh, I didn't implement it in the model. That's very stupid. So let's write a very basic model for creatinine clearance, just the 1 over the creatinine value, which is probably not a very good model, but let's go with this for now for the demo. Not sure why it's not working. Oh, I see. Again, made an error in the model because I wasn't using the individual clearance. So now you can see that that it's actually changing over time. The clearance is getting much lower over time. One thing to note here is that by default, if you implement a covariate as varying over time, it will interpolate those values. So it will, in this case, it will gradually move from 0.5 to 2 to 4 and 5 with linear interpolation. If you want to use sort of a last observation carried forward, or like a step function, that's very easy. You just say implementation is LOCF, and then you have to recompile the model as well for that change. But now the value of the covariate will actually change less gradually, and will be implemented as a step function. It's a bit easy to see now that it's less gradual. So I think I've this is more or less what I wanted to show. Let me see if no, this is more or less the end of what I wanted to show. Let me just see if I have any questions on Twitter. No, that's good. I hope this was clear, and let me know if you have any questions later on. I'll be happy to answer them on the GitHub page, or yeah, on the email. Okay, thanks for watching, and yeah, maybe until a later time. Bye bye.